Have you ever held something in your hand, something small, and felt the immense weight of time? Not just its physical weight, but the gravity of the eons it has witnessed. Deep within the pyrophyllite mines of South Africa, miners uncovered small spherical objects, now known as the Klerksdorp spheres. These aren't just rocks, they're enigmas. Some are perfectly round, others are oblong, and many have these peculiar parallel grooves etched around their equator. They were found in a mineral deposit that is, geologically speaking, ancient. We're talking about 2.8 billion years old. That's billion with a B. Before almost everything we recognize as complex life. This incredible age has led to some truly fascinating and some might say wild speculation. Could these spheres be artifacts? The handiwork of an intelligent civilization that existed on Earth billions of years ago, a civilization lost to the sands of time? Proponents of this idea, often called out-of-place artifact or OOPArt theorists, point to the sphere's precision and uniformity as evidence of intelligent design. But on the other hand, geologists and scientists offer a different, though no less fascinating explanation. They argue these are natural formations called concretions, created through a process of mineral precipitation over millions of years. It's a battle between extraordinary claims and grounded scientific explanation, but the Klerksdorp spheres are not alone in their mystery. They are just one piece of a much larger global puzzle. All around the world we find objects that seem to defy their historical context. An ancient computer from a Roman shipwreck, a potential battery from ancient Mesopotamia, a modern-looking hammer encased in rock that's supposedly millions of years old. These artifacts challenge our understanding of the past and force us to ask a profound question. What if our history is not as we've been told? What if there are chapters of our story that have been completely lost? Today we're going to dig into these mysteries, and as always, thanks for watching. So, let's start with the spheres. The Klerksdorp spheres. Imagine you're a miner, deep underground in Ottosdal, South Africa. You're breaking apart layers of pyrophyllite, a soft metamorphic rock, and out pop these little metallic-looking balls. Some are just a few millimeters across, others up to 10 centimeters. They feel heavy, dense, and the most striking feature? The grooves. 1, 2, or even 3 perfectly parallel lines running around the middle. How could nature possibly create something so deliberate? This is the core of the mystery, the question that fuels the entire debate. Proponents of the ancient intelligence theory, people like Michael Cremo, author of Forbidden Archaeology, argue that these spheres are impossible to explain through natural processes alone. They claim the balance and precision of the spheres are so perfect that they must have been manufactured. Some have even gone so far as to say that NASA scientists, upon examining them, were baffled, stating they could only have been made in zero gravity. This claim, however, is difficult to substantiate and often circulates without a primary source, a common feature in the world of pseudo-scientific arguments. It's a compelling story, but is it a true one? The narrative is powerful. A lost civilization predating the dinosaurs, leaving behind these small, curious calling cards. It taps into our desire for a more magical, more mysterious past. The idea that we are not the first, that great empires of unimaginable antiquity rose and fell, is a tantalizing thought. These spheres become more than just rocks. They become potential proof of a history so deep it has been almost entirely erased, a history that could rewrite everything we know about life on Earth. The grooves in this context are not accidental. They are a design, a feature, maybe even a form of communication. But what does geology say? What is the scientific consensus? Geologists almost universally identify the Klerksdorp spheres as concretions. A concretion is a hard, compact mass of matter formed by the precipitation of mineral cement within the spaces between particles. It's a process that happens all over the world. You might have seen them yourself, strange round rocks weathering out of a cliff face or riverbank. They often form around a nucleus, like a tiny fossil or a grain of sand, with minerals slowly accumulating around it in concentric layers like an onion or a pearl. This process can absolutely create spherical objects. As minerals radiate outwards from a central point in a uniform medium, a sphere is the most natural shape to form. Think of how a raindrop becomes spherical due to surface tension. It's a matter of physics and chemistry playing out over immense geological timescales. The material of the Klerksdorp spheres, identified as hematite or wollastonite mixed with hematite and goethite, is consistent with the mineral makeup of the surrounding pyrophyllite deposits. They aren't made of some exotic, unknown metal, they are made of earth. So what about those grooves? The perfectly parallel lines that seem so artificial. According to geologists like Bruce Cairncross, a professor at the University of Johannesburg, these are also natural. The spheres formed as concretions within soft, unlithified volcanic sediment. As this sediment compacted and eventually turned into the pyrophyllite rock we see today, it would have squashed the still-forming, slightly soft concretions. The grooves, then, are simply where the surrounding fine-grained sedimentary layers intersected the growing sphere. They are, in essence, tiny stratigraphic planes. It's a phenomenon called septarian concretion, though the Klerksdorp spheres are a slightly different variation. The idea is that the internal structure and the external features are a direct result of the geological environment in which they were born. The perfect balance often touted is also questionable. While some are remarkably spherical, many are flattened or oblong, which is consistent with the compaction theory. They are not the perfectly machined ball bearings that some descriptions would have you believe. Many have been cut open, revealing a radial structure inside, exactly what you'd expect from a concretion, not a solid manufactured artifact. But the story doesn't end there. There's another layer to this. Some spheres are hollow. When you shake them, you can hear a smaller object rattling around inside. This too sounds incredibly artificial, like a child's rattle made by an ancient god. However, this is also a known feature of concretions. Sometimes the inner core of the concretion is less resistant to weathering than the outer shell. Over millions of years, the center can dissolve or shrink, leaving a hollow space and sometimes a loose bit of material inside. It's a natural geological miracle. So we are left with two competing narratives. One is a story of myth, mystery, and a lost, technologically advanced civilization. It's a story that sparks the imagination and challenges the foundations of history. It asks us to believe in the extraordinary, to see intelligence and design where others see only rock. It's a tale of forbidden knowledge, a history that they don't want you to know. It's exciting, and it makes the world feel bigger and more full of secrets. The other narrative is a story of geology, of deep time, and the slow, patient, and often bizarre processes of our planet. It's a story of chemistry, pressure, and time. It explains the spheres not as the work of hands but as the work of the Earth itself. It might seem less romantic, but it's a testament to the fact that nature is often a far more creative and surprising artist than we give it credit for. The truth, as is often the case, might be less sensational, but it is, in its own way, just as wondrous. The Klerksdorp spheres are not a message from the past, but they are a message the past, a message from a 2.8 billion-year-old Earth. Now let's fast forward, a lot, from 2.8 billion years ago to just over 2,000 years ago, and let's travel from the mines of South Africa to the crystal-clear waters of the Aegean Sea. In the year 1900, a group of Greek sponge divers took shelter from a storm near the island of Antikythera. When the storm passed, they dived, and what they found was astonishing, a Roman-era shipwreck, littered with marble statues and other treasures. But among the priceless art was something else. A lump of corroded bronze and wood that, at first, looked like just another rock. It wasn't until an archaeologist noticed a gear wheel embedded in the lump that they realized they had something special. This corroded lump was brought to the National Archaeological Museum in Athens, where for decades it sat, largely unstudied. It was a puzzle. Early examinations were difficult, but over the years, with the advent of more advanced imaging technology like X-rays and CT scans, a breathtaking picture began to emerge from within the corroded bronze. This was not a rock, it was a machine of mind-boggling complexity. What the scientists uncovered was a system of over 30 interlocking bronze gears, dials, and pointers. This device, now known as the Antikythera mechanism, was an analog computer. Let that sink in. An analog computer from ancient Greece. Before its discovery, our understanding was that the engineering skill to create something like this didn't exist until the great astronomical clocks of 14th century Europe, over 1,000 years later. This single discovery fundamentally rewrote the history of technology. It was like finding a jet engine in Tutankhamun's tomb. So what did it do? By turning a hand crank, the user could set the mechanism to a specific date. The gears would then whir into motion, and a series of pointers on the front and back dials would display an incredible amount of astronomical information. It showed the position of the sun and the moon in the zodiac. It predicted lunar and solar eclipses with startling accuracy down to the hour. It even accounted for the variable speed of the moon's orbit using a clever pin-and-slot mechanism that mimicked Kepler's laws of planetary motion, laws that wouldn't be formally described for another 1500 years. The back of the mechanism was just as impressive. It featured two large spiral dials. One was a 223-month cycle known as the Saros cycle, used for predicting eclipses. The other was a 19-year cycle, the Metonic cycle, which was crucial for harmonizing the solar and lunar calendars. It even had a smaller dial that tracked the timing of the ancient Olympic Games and other pan-Hellenic festivals. It wasn't just an astronomical calculator, it was a social and religious calendar. It was the iPhone of its day, connecting the heavens to life on Earth. The sheer sophistication is what shocks historians and scientists. The gears were cut with triangular teeth, a design that requires precision and a deep understanding of mechanics. The differential gear system, which was used to calculate the lunar cycle, was a technology that was thought to have been invented in the 16th century. The text inscribed on the device, a sort of user manual, reveals a deep and complex understanding of Babylonian and Greek astronomy. It represents a level of mechanical and scientific knowledge that was thought to be completely lost during the subsequent centuries. Why was it lost? That's one of the biggest mysteries. The Antikythera mechanism implies that there must have been a tradition of this kind of complex mechanical engineering in the Hellenistic world. It's highly unlikely that this was a one-of-a-kind device. There must have been others, perhaps simpler ones that came before it and maybe even more complex ones that came after. But if so, where are they? Why have we found no other examples? It seems that this entire branch of technology simply vanished from the historical record. One theory is that the knowledge was simply not widespread. It may have been the domain of a very select group of philosophers or engineers. Another is that the materials were the problem. Bronze was valuable. It's possible that as the Roman Empire declined, these complex machines were simply melted down for their metal to make swords or coins. A book can be copied, but a complex machine made of a valuable resource is easily lost forever. It's a sobering thought that entire fields of knowledge can be so fragile. The mechanism forces us to reconsider our view of the ancient world. We often think of the Greeks and Romans in terms of philosophy, art, and architecture. We think of marble statues and grand temples. We don't typically think of them as master machinists and computer builders. But the Antikythera mechanism proves that they were. It's a tangible link to a level of scientific thought we didn't know they possessed. It shows a desire not just to observe the cosmos, but to model it, to replicate its beautiful, predictable clockwork in a handheld human-made device. Unlike the Klerksdorp spheres, there is no debate about whether the Antikythera mechanism is artificial. It is unequivocally a product of human intelligence. The mystery here is not about its origin, but about its context. How could something so advanced exist in its time, and how could that knowledge be so completely lost? It's a ghost from a forgotten technological past, a beautiful, intricate ghost that reminds us that history is not a simple, linear progression. Sometimes, knowledge is gained, and then tragically it is lost, waiting centuries to be rediscovered. Let's move from a complex machine whose purpose is clear to a simple object whose purpose is anything but. Our next stop is Mesopotamia, modern-day Iraq, the cradle of civilization. In 1936, near Baghdad, workers excavating a railway discovered an ancient village, and in the ruins, they found a peculiar object, a small terracotta pot, about 13 centimeters high. Inside the pot was a copper cylinder, and inside the cylinder was an iron rod held in place at the top by an asphalt or bitumen stopper. This humble-looking assembly is known as the Baghdad battery. What makes it so controversial? Well, if you look at its components, a pot, two different metals, and a space for a liquid, it bears a striking resemblance to a galvanic cell, a simple type of battery. If you were to fill the pot with an acidic liquid like grape juice, vinegar, or even just salty water, the chemical reaction between the copper and the iron would generate a small but measurable electric current, a voltage of somewhere between 0.5 and 2 volts. It's not much, but it's definitely electricity. The idea was first proposed by Wilhelm Koenig, the German director of the National Museum of Iraq, shortly after its discovery. He noted the similarity to modern batteries and speculated that these ancient pots could have been used for electroplating, applying a thin layer of one metal like gold or silver onto another. This would have been an incredibly advanced technique for the Parthian or Sasanian periods, roughly 250 BC to 650 AD, to which the pots are dated. Imagine ancient artisans using electricity to gild jewelry or ornaments. This theory captured the public imagination. It was another potential oopart, an out-of-place artifact. The idea of ancient electricity is thrilling. It opens up all sorts of possibilities. Could they have used it for more than just electroplating? Some have speculated about its use in religious rituals, perhaps to create a tingling sensation to awe worshippers when they touched a metal statue. Others have suggested it could have been used for a form of primitive medical therapy, a sort of electroacupuncture. The possibilities seem endless. Shows like Mythbusters have tested the theory. They built replicas of the Baghdad battery and were successfully able to generate a current and even electroplate a small token with a thin layer of metal. So it's possible the device could work as a battery, but just because something can be used for a certain purpose doesn't mean it was used for that purpose. This is where the skepticism from mainstream archaeologists and historians comes in. And their arguments are quite compelling. First, there is the context, or rather, the lack of it. We have found these jars, but we haven't found anything that would go with them to form a complete electrical circuit. There are no wires, no conductors, no electroplated objects that can be definitively linked to this specific time and place. If this was a common technology, even a secret one, you would expect to find some of the associated paraphernalia. We simply haven't. The batteries, if that's what they are, exist in a vacuum. Second, the construction itself has some problems. The bitumen stopper completely seals the top of the copper cylinder, making it difficult to add or replenish the electrolyte liquid inside. Also, the iron rod shows signs of corrosion, which is what you'd expect. But the copper cylinder is often not corroded, which is strange if it was part of an active electrochemical cell. An active battery should corrode both electrodes. These details suggest another, more mundane purpose. What is that purpose? The most widely accepted archaeological explanation is that these pots were simply containers for sacred scrolls. In this theory, the copper cylinder would have protected a scroll made of papyrus or parchment. The iron rod might have been used to wrap the scroll around, and the bitumen seal would have kept the contents safe and dry. Similar vessels for storing scrolls have been found elsewhere in the region, most notably at Seleucia, another Mesopotamian city. This explanation accounts for all the components without needing to invoke a lost high-tech past. So, we have a classic case of interpretation. Is it an ancient battery, a testament to a forgotten form of science? Or is it a storage jar, a perfectly logical and well-documented type of artifact from the ancient world? The evidence for the battery theory is circumstantial. It looks like a battery and it can be made to function like one. The evidence against it is contextual. We have no other proof of ancient electrical technology, and a simpler, more plausible explanation exists that fits the archaeological record. The Baghdad battery remains an enigma. It's not as clear-cut as the Antikythera mechanism, which is undeniably a machine, nor is it as easily explained by natural processes as the Klerksdorp spheres. It sits in a fascinating gray area. It forces us to ask how we interpret evidence and how much we let our modern knowledge influence our view of the past. It's a reminder that sometimes the simplest explanation is the most likely one, but not always the most exciting. Our next mystery takes us to the much more recent past, at least in terms of its discovery. The year is 1936, or perhaps 1934, the stories vary. A couple, Max and Emma Hahn, are out for a walk near the town of London, Texas. They spot a curious piece of rock, a concretion, with a piece of wood sticking out of it. They take the interesting rock home and leave it in their garden for years. About a decade later, their son breaks the rock open with a hammer and chisel, and inside, they find something incredible. What they found was an iron hammerhead, of a surprisingly modern design, attached to a partially petrified wooden handle. The hammerhead was encased in the rock. This artifact became known as the London Hammer. The rock it was found in, the concretion, was claimed to be from the Ordovician period, which would make it over 400 million years old. A modern-looking hammer, found inside 400-million-year-old rock. The implications, if true, are staggering. It would predate not just humans, but dinosaurs, land plants, almost everything. The hammer was eventually acquired by the creationist Carl Baugh, who now displays it in his Creation Evidence Museum in Glen Rose, Texas. For Baugh and other young Earth creationists, the hammer is proof against the geological timescale and the theory of evolution. Their argument is simple. This is a human artifact, clearly, so the rock it's in cannot be millions of years old. Instead, they propose that the rock was formed rapidly during the biblical flood of Noah, encasing a pre-flood hammer. It's a cornerstone exhibit for a very specific worldview. Let's look at the hammer itself. The metal of the head is unusual. Analysis has shown it to be composed of 96.6% iron, 2.6% chlorine, and 0.74% sulfur. This is a strange composition for modern steel, which usually contains carbon. Proponents claim this shows it was made with a lost, advanced pre-flood technology that could create stainless iron. The wooden handle is also interesting. Part of it has turned to coal, a process that supposedly takes millions of years, further deepening the mystery. However, as with our other artifacts, there's a more skeptical, scientific perspective, and it starts with the rock. The claim that the concretion is Ordovician is highly questionable. Geologists who have studied the area state that the rock is likely a much younger Cretaceous concretion, maybe 100 million years old. But more importantly, concretions can form very quickly under the right chemical conditions. Not over millions of years, but potentially over just a few decades or centuries. Think about it. A miner in the 19th or early 20th century drops his hammer. It falls into a crack in the limestone. Water, rich in dissolved minerals, seeps through the ground. The iron of the hammerhead acts as a nucleus, and the minerals begin to precipitate out of the water and solidify around it. Over a relatively short period of time, a hard, rock-like concretion forms around the hammer, making it look like it's been there for eons. This process is well documented. We've found spark plugs and other modern objects inside similar concretions. This explains how a modern object can end up inside what looks like ancient rock. The rock isn't ancient, it's modern rock that formed around an old but not ancient tool. What about the hammer's design? While proponents call it modern, it's actually a very common type of miner's or blacksmith's hammer from the late 19th century. It's not some futuristic tool. It's a perfectly normal historical artifact from a time when mining was common in that area of Texas. And the strange metal composition? The lack of carbon is what you'd expect from wrought iron, which was common before the widespread adoption of modern steelmaking processes in the early 20th century. The high chlorine content is likely due to contamination from the groundwater it was soaking in for decades, and the partially coalified handle, the dark blackened appearance is not true petrification or coalification, it's simply the result of organic material being buried in a mineral-rich, oxygen-poor environment. The wood is old and chemically altered, but it's not millions of years old. So the London hammer is a fascinating object, but perhaps not for the reasons its promoters claim. It's not evidence of pre-flood giants or time travelers. Instead, it's a perfect example of how geological processes can be misunderstood. It shows how a perfectly normal object, through a rapid and interesting natural process, can be transformed into something that looks like an impossible artifact. It's a geological trick, a natural illusion. The story of the hammer is a powerful lesson in critical thinking and the importance of context. The initial claim is sensational, a 400-million-year-old hammer. But once you examine the evidence, the nature of concretions, the design of the tool, the history of the region, the chemistry of the metal, a much more plausible and frankly more elegant explanation emerges. The mystery isn't in the object itself, but in the way it has been interpreted and presented to the public. For our final mystery, we return to the Mediterranean, to the Greek island of Crete, and we're not looking at an object made by hands but an impression left by feet. In 2002, a Polish paleontologist named Gerard Gierlinski was on holiday in western Crete. He stumbled upon a set of fossilized footprints near the village of Trachilos. But these weren't dinosaur tracks. They looked human, or at least very human-like. This discovery, after years of study, would send shockwaves through the world of paleoanthropology. What's so shocking about human-like footprints? It's all about the when and the where. The rock layer in which the Trachilos footprints were found has been reliably dated to 5.7 million years ago. At that time, according to our established understanding of human evolution, our pre-human ancestors, or hominins, were believed to be living only in Africa. Famous fossils like Lucy, Australopithecus afarensis from Ethiopia, dated to 3.2 million years ago, showed a creature that was only beginning to walk upright and still had very ape-like feet. The Trachilos footprints, however, tell a different story. The prints show a creature with a distinct ball of the foot, 5 short toes with no claws, and a prominent big toe, or hallux, that is in line with the other toes, not splayed out to the side like an ape's for grasping branches. This is the foot of a biped, a creature that walked upright on the ground. To find such a foot 5.7 million years ago is remarkable. But to find it in Crete, in Europe, is revolutionary. It challenges the entire out-of-Africa narrative at its very earliest stages. The established theory is that the first hominins evolved in Africa and stayed there for millions of years. The first migration out of Africa was thought to be by Homo erectus, around 1.8 million years ago. The Trachilos footprints are 4 million years older than that. If they were made by a hominin, it means that our earliest ancestors may have been wandering through Europe at a time when we thought they were confined to the African continent. This would be a massive paradigm shift. Naturally, a claim this extraordinary has faced intense scrutiny and skepticism. One of the main counter-arguments is that the prints weren't made by a hominin at all. Some researchers have suggested they could belong to a primate from an extinct European ape lineage like Greco-Pithecus, which lived in the region around that time. Perhaps this group of apes evolved bipedal, human-like feet independently of the African hominin line. This is a concept known as convergent evolution, where different species develop similar traits to adapt to similar environments. However, the team that studied the footprints, led by Per Ahlberg at Uppsala University, argues that the features are too specifically hominin-like. The combination of a ball, a non-divergent big toe, and the overall sole shape is a hallmark of our lineage. They contend that while convergent evolution is possible, the simplest explanation is that these prints were made by an early, unknown member of the human family tree. The debate is fierce and ongoing, representing a fundamental disagreement about our own origins. The geological context adds another layer of intrigue. 5.7 million years ago, during a period known as the Messinian salinity crisis, the Mediterranean Sea temporarily dried up, or at least its level dropped dramatically. This would have created land bridges connecting Africa, Europe, and Asia. It's plausible that early hominins could have walked from North Africa to Crete during this time. The footprints were found in what was once the sediment of an ancient shoreline, a perfect place to preserve the tracks of an animal coming to the water's edge. The story of the Trachilos footprints is a perfect example of how science actually works. A discovery is made that doesn't fit the current model. It's met with skepticism. Alternative explanations are proposed. More evidence is gathered. The original hypothesis is tested again and again. It's a slow, rigorous, and often contentious process. Unlike some of our other mysteries which have been co-opted by pseudoscience, this is a genuine scientific debate happening right now at the frontiers of human knowledge. The footprints are not an artifact in the traditional sense. They are a trace fossil, a fleeting moment from 5.7 million years ago captured in stone. A moment when a creature, perhaps one of our own distant ancestors, walked along a beach on an island that was, for a brief geological window, connected to Africa. It's a discovery that doesn't offer easy answers. Instead, it asks profound questions. Was our family tree more like a branching bush than a straight line? Were there multiple cradles of humanity? Did our ancestors leave Africa far earlier than we ever imagined? The Trachilos footprints force us to be humble, to admit that the story of our own species is still being written, or rather still being unearthed. Each new discovery, whether it's a bone, a tool, or a simple set of footprints in ancient mud, has the potential to add a new, unexpected chapter. So, from 2.8 billion-year-old spheres to 5.7 million-year-old footprints with ancient computers, batteries, and hammers in between. What do all these objects have in common? They are all pieces of a puzzle. A vast, incomplete puzzle of our planet's and our species' history. Some pieces, like the Antikythera mechanism, click satisfyingly into place, revealing a picture of the past that is more complex and brilliant than we imagined. Others, like the Klerksdorp spheres and the London hammer, seem to fit better when we realize that the piece itself has been shaped by natural forces into something deceptive. They teach us about geology as much as history. Then there are the pieces that don't seem to fit anywhere yet, like the Baghdad battery and the Trachilos footprints. They sit on the table, challenging us. They could be the corner piece of a whole new section of the puzzle we haven't even started. Or they could be from a different puzzle box entirely. A misinterpretation, a red herring. The debates surrounding these artifacts are not a sign of science failing. They are a sign of science working. It is the process of questioning, testing, and re-evaluating that pushes our knowledge forward. Every mystery is an invitation to learn more. The world is full of these invitations. It's easy to jump to sensational conclusions, to believe in lost super-civilizations or time travelers. And while those are exciting ideas, it's often more rewarding to dig deeper, to understand the context, to learn about geology, chemistry, and archaeology. The real world, with its complex natural processes and its messy, surprising history, is often more wonderful than any fiction. So, keep asking questions, keep being curious, and never stop digging for the truth, wherever it may be buried. Because the greatest treasure is not the artifact itself but the understanding we gain from studying it. And as always, thanks for watching.